Okay, we're going to go over compound interest today. We're going to use this example. Tyler has a savings account that gives him 3.9% annually, compounded monthly. Okay. Tyler plans on putting $2,000 and leaving it in the account until he's 25 years old. Tyler is now 18 years old. How much money will he have in his account when he is 25 years old? So there's a lot of information we got to go over here. Now, yesterday we talked about simple interest. Today we're going compound interest. Okay? Compound interest is this formula here. And this formula,
so why would
as you guys
interest work for this?
Pardon?
Why wouldn't the simple one work for this?
Because simple interest won't get us the same amount of money. And what we'll do is we'll do both of them so that you guys can see the difference between the two. Okay? Now, what you guys need to know is you need to know some of these definitions. A is the total amount. Okay? So we'll call it total amount. Our P is still principal. Now, our other two variables, which are I and N, are a little different. Okay? What we'll do is we'll color code some of this for you. So A will be black, P will change the color. We'll do that purple. Okay, I. I actually is the interest you're going to earn per compound period. And what they mean by that is I is actually a little equation. We have it over here. And what this stands for, let me put it over here. I is R divided by C. Now our R, we'll give that a color, is the actual interest rate.
Is that nice?
Yeah. Formulas within formulas. God.
Okay. So R is the interest rate. And what that means, so we do R, is whatever our interest rate is, which we have here, 3.9%, that's what R stands for. Now, we don't put it in as a percentage. What do we put it in as?
Decimal.
Decimal. How would I make that a decimal?
0.03. No, 0.039.
Divide by 100, or also known as 0.039. The other part of it is C. Does anyone have an idea of what the C might stand for?
C stands for...
What was it?
Cost.
Compound.
What did you say it for? Compounding period. Okay? The compounding period is monthly in this one. So in other words, monthly, how many months? Because he's getting 3.9% annually, compounded monthly. How many months are in a, or what does annual stand for?
Year.
Every year. So how many months in a year?
12.
Good. So it's important that you guys know that in this case, C is going to be equal to 12. The other number we have, or other variable, let's say, we'll change this color.
Wait, sir, why wouldn't you make C like 17 years? Because it's leaving it in for 25 years.
Oh, we'll get to it. N is again another formula. N itself is YR. Anyone know what YR might stand for?
Not even the rest of
Years.
Years. So it's our years multiplied by compound period. Okay? And in other words, N stands for the number of periods that pass. Okay? So, how many years do we say are going to pass? Do we know?
17.
20, no, yeah.
Other way around. 25 minus 18? No, it's not. 25 minus 18 gives you what?
17?
Tricked you!
8. 5.
All right.
7.
7.
7 years.
7. Good.
7, yeah. 17.
7.
James.
Okay, so
Got you.
our years, in this case, are going to be 7 years. Our compound period, C, is 12. Our interest rate, R, is 3.9. Okay. So we have a couple of the basic ones. Our principal, P, is going to be what? $2,000.
Yes.
Is that all we have? P, R, YR, and C. Good. We need to calculate our I. So I is the interest rate, which is 0.039 divided by 12. So we calculate that here, 0.039 divided by 12. So we write this number down. 0.00325. That's what our lowercase I stands for. And our N, is equal to the 7 years times 12. Anyone know what that's going to be?
72. 84.
84. So what that means is 84 months are going to pass in these 7 years. So that's how many times this guy's going to compound money. So we have our major variables here for our equation. So we'll highlight them. Our P is 2,000. Our I, whoops, this is our answer. That's the number we're going to put in for I. And our N is 84. So we're going to plug these values in, and we're trying to find the future value, the amount. Let's change that. So our amount is equal to the number 2,000 times 1 plus 0.00325 to the power of 84. Okay. So first of all, we deal with brackets first in BEDMAS. We'll get 1.00325. And it's compounded 84 times. So we take this number here, plus 1, to the power of 84. And instead of writing this down, because I know most of you guys will end up rounding, and in fact what I'll do is, I'll write the rounded version just so you have an idea. Most of you guys probably write 1.31, something like that. I'm going to take this value and instantly multiply it by 2,000. So, the amount of money that we have earned, or that we'll have, sorry, when we're 25 years old, is $2,626.63. Now, had I just used this number here, 2,000 times 1.31, I would have lost $6 in my calculation. Okay? Doesn't seem like a lot, but when we're using large sums of money, especially maybe even mortgages, stuff like that, you're going to end up losing quite a bit of money if you guys start to round early. Okay? So it's important to try to make it as accurate as possible.
Yes, sir. So you
Second question. You're offered 2 bank accounts. One account gives you 3% annually. The other one, compounded monthly. The other one offers you 2.5% annually, but compounded daily. You'll probably leave your money in the bank for about a year before you need to take it out. Which would be best if you invest $1,000? So, our actual formula is the compound interest formula. Okay. We're doing this and we're trying to find A. We need to write down what our variables are for each. So I'll do the first one in red. R is 3%, or also known as 0.03. We have to divide that by 100. Our years are just 1. And our compound period is monthly, therefore there are 12 months in 1 year. Okay, because he's doing it annually. Also, our principal is $1,000. In our other example, R is 2.5%, or 0.025. Years are the same. Compound period is different. It's every day. So how many days in a year? 365. And the reason we refer to a year is because it's annual. The interest rates are annual. And our principal is still $1,000. So, let's calculate these. A is equal to 1,000.
I messed up.
We need to actually calculate I. I is interest rate, which is 0.025, divided by 365. Okay, so 0.025 divided by 365 is a very small number. Now, instead of writing 1 plus this, I know that it's going to be 1 point, whatever this decimal is, so I'm just going to write it like that. 1 point. How many zeros are there, Nick? 4. 1, 2, 3, 4, 6, 8, 4. So many of you, this is pretty far along. That's probably okay. And the other thing we need to calculate is our number of years times our compound period. Well, because there's only 1 year, 1 times 365 is 365. So again, instead of rounding, even though I've rounded my question on my calculator, I'm going to leave that large decimal, add 1 to it, and then put it to the power of 365. I get another decimal times 1,000, and we get $1,025.31. So how much interest did we earn in the course of a year? $25.31. That's pretty good. It's not bad.
Is it actually good?
It's a decent interest rate. And our other one, 1,000. Now, again, our interest rate, we need to take 0.03, but this time we divide by 12 because it's monthly. So 0.03 divided by 12 gives us 0.0025. Okay, so our I is 0.0025. And again, instead of putting 1 plus that, I know it's going to be 1.0025. Our N, 1 year times 12 months, is just 12. So I'm going to add 1 to this number in my calculator, put it to the power of 12, and then multiply by 1,000. And the 3% still earns us more money. Okay? I'll earn an extra $5. $5 is still $5. Now, what I want you guys to do is change the timeline. What if this is over the course of 5 years? Let's see. 10 years and 50 years. They're not really big changes. We have a lot of the numbers already. The only things that are going to change here are going to be, no, our compound period stays the exact same.
Why?
Right? The only thing that changes is our exponent. The number of years is changing. So our I will stay the exact same in both. It's our exponent that's going to be different. Instead of being 12 times 1, it'll be 12 times 5, then times 10, then times 50. Same with 365. Instead of times 1, times 5, 10, and 50.